Welcome to the lesson on solving systems of equations. This is a review lesson, so if you need additional resources, please click on the resource tab on the website. This will lead you to more videos on this topic from Khan Academy. If you have any questions, you can go to the main lesson page, scroll down, and add a question to the chalkboard below. All right, so let's go ahead and get started with solving systems of equations. When we have systems of equations, we have three possibilities. One is that the two lines intersect at one point, so we get one solution. The second is that the two lines are parallel, which means that they never cross, which means that they never have anything in common, so there is no solution. And the third option is that they are the same line, so there's infinitely many solutions. Now, one of the misconceptions is that it's two separate lines laying on top of each other. A line has no thickness. If something has no thickness, that means it cannot lie on top of another thing. So when we look at infinitely many solutions, it's just two different representations for the same line, which means the same set of points. So let's go ahead and explore solving systems of equations by graphing. So when we solve systems by graphing, right, this is an example of a system, y equals x minus 2 and 2x plus y equals 1. So here in a system, we have two linear equations. So to solve by graphing, we are going to graph both equations on the same graph and find out where they meet. So to graph y equals x minus 2 and 2x plus y equals 1, we want to make sure that both of them are in slope-intercept form because that makes it a little bit easier to graph. The first equation, y equals 2 minus x, is in slope-intercept form, where our slope is equal to 1 and our y-intercept is equal to negative 2. So let's go ahead and take a look at 2x plus y equals 1. To get it into slope-intercept form, I want to get y by itself, so I'm going to subtract 2x from both sides, and I get y equals negative 2x plus 1. So for my first line, like I said, our y-intercept is negative 2 and our slope is 1. So I'm going to go up 1 to the right 1, up 1 to the right 1. For our second line, our y-intercept is positive 1 and my slope is negative 2. So I'm going to go down 2 to the right 1, down 2 to the right 1. So let's go ahead and start with the y-intercept for the first line. We have the point at negative 2, and we are going to go up 1 to the right 1, up 1 to the right 1, and we draw our line. Now for our second equation, we have a y-intercept of positive 1, so I'm going to go up to 1, and then my slope is going to go down 2 to the right 1, and you can see that we overlap that same point at 1, negative 1. When we solve a system by graphing, we want to solve graphs where our solutions are points that have whole numbers. It's easier to see where they overlap. So for example, this solution at 1, negative 1 is very clear to see that they both meet at that point. So let's go ahead and take a look at solving systems algebraically. What happens if our points are not as easy or our lines are not as easy to graph as that previous example? So our first example solving systems algebraically is to solve the system by substitution. If we have a system y equals x plus 5 and 4x plus y equals 20, what I'm going to do is I'm going to take the value for y in the first equation and plug it into y in the second equation. So my system, for the first equation, y equals x plus 5. So I'm going to take that quantity of x plus 5, that is the same thing as y, and plug it into the place where y was in the second equation. So my second equation becomes 4x plus x plus 5, which is that value for y, is equal to 20. So my first equation is going to stay the same. My second equation is going to become simplified. So my first equation remains y equals x plus 5. My second equation, I'm going to combine like terms. 4x plus x is equal to 5x. So I get 5x plus 5 equals 20. Now I'm going to go ahead and solve for x with that second equation. So I'm going to subtract 5 from both sides. My first equation stays the same. Y equals x plus 5. My second equation becomes 5x equals 15 once I subtract 5 from both sides. Now in that second equation I want to solve for x, so I'm going to divide both sides by 5. First equation stays the same. Second equation we get x equals 3. Now once I know what x equals, I can plug that value for x into the value for x in the first equation. So we get y equals 3 plus 5 after I substitute 3 for x. And we get y equals 8 once we simplify there. So my x value is 3, my y value is 8, so the solution to this system is 3, 8. Let's take a look at another example solving a system by substitution. Our system is y equals 5x minus 10 and y equals 3x plus 8. So again, we're going to substitute the first value for y in for y in the second equation. So my first equation is going to stay the same, y equals 5x minus 10. Then I'm going to take what y equals, 5x minus 10, and substitute that in the place of y for the second equation. So we get 5x minus 10 is equal to 3x plus 8. Now I want to solve the second equation for x, leaving the first equation the same. All right, so for the second equation, I'm going to subtract 3x from both sides and add 10 to both sides so that my x values move to the left and my constants move to the right. So I get 2x equals 18. To get x by itself, I'm going to divide both sides by 2. First equation staying the same. So we get x is equal to 9. Now I'm going to take that value x equals 9 and substitute it in for x in the first equation. So my first equation becomes y equals 5 times 9 minus 10. 5 times 9 is 45, minus 10 is 35. So I have my x value is 9, my y value is 35, so the solution to this system is 9, 35. That's where these two lines will meet. Our third example using substitution, our system is 3x plus y equals 2 and 4x plus y equals 20. Now, when I look for solving with substitution, I have to have a variable equals a value in order to substitute. So here I see y and y, but neither of them are y equals and y equals. So what I want to do is take that first equation and get y by itself. So to get y by itself, I'm going to subtract 3x from both sides. So that becomes y equals negative 3x plus 2, and the second equation is 4x plus y equals 20. So now I'm going to take that value for y from the first equation and substitute it in for the value of y in the second equation. So I'm going to take that negative 3x plus 2 and put it in the place of y for the second equation. Let's go ahead and simplify that second equation. 4x minus 3x gives me 1x plus 2 equals 20. Subtract 2 from both sides and I get x equals 18. Now I'm going to take the value 18 and plug it in for x in the first equation. Y equals negative 3 times 18 plus 2. Negative 3 times 18 is negative 54 plus 2 is negative 52. So my x value is 18, my y value is negative 52. This is the solution to the system. All right, for our fourth example with solving a system by substitution, my first equation in the system is y equals negative x plus 3, and my second equation is x plus y minus 3 equals 0. So I'm looking to substitute a variable for a variable. So I see y equals negative x plus 3. I'm going to take the value for y, negative x plus 3, and substitute it in for y in the second equation. So for our first equation, it stays the same. Our second equation, we're taking that negative x plus 3 and putting it in the place of y. So we get x plus negative x plus 3 minus 3 equals 0. So when I simplify that second equation, x plus negative x is 0, and 3 minus 3 is 0, so I get 0 equals 0. That means that my x value is completely eliminated, and it is a true statement. 0 is equal to 0, therefore I have infinitely many solutions. That means that these two lines are just different representations of the same line. All right, next are solving the system with substitution. I have 3x plus y equals 6 and y equals negative 3x plus 2. So I have y equals for my second equation. So that means we're going to kind of change the order than what we've seen before. So I'm going to take the value for what y equals in the second equation, negative 3x plus 2, and substitute it in the place of y in the first equation. So my first equation becomes 3x plus negative 3x plus 2 equals 6. So I'm going to look to simplify my first equation and solve for x. When I simplify that first equation, I get 3x plus negative 3x is 0x. So I end up with 2 equals 6. Now that's a contradiction. 2 will never equal 6, and 6 will never equal 2. So since we end up with a contradiction, our solution is no solution at all. Okay, so now we're going to explore solving systems through elimination. So our rules that we need to use when solving a system by elimination is, 1, we are allowed to add equations together. So if I have 2x plus 3y equals 6 and 5x plus 2y equals 10, I can add these two equations, making sure that I combine like terms. So my x terms go together, my y terms go together, and my constants go together. So 2x plus 5x is 7x. 3y plus 2y is 5y, and 6 plus 10 is 16. The second rule is that we can multiply both sides of an equation by a number. So for example, if I have 2x plus 3y is equal to 6, I can multiply both sides of the equation by negative 1. I just have to make sure that I distribute to the negative 1 to every term in the equation. So I'm going to get negative 2x minus 3y equals negative 6. Okay, once we know those rules, solving by elimination is possible. So when I solve by elimination, I'm looking at a system like 2x plus 5y equals negative 24 and 3x minus 5y equals 14. Typically, when we solve by elimination, you see both the x terms and the y terms on the same side of the equation like we have here. Now, if we take a look at the y term, I have positive 5y in the first equation and negative 5y in the second equation. So if I add these two equations together, 5y minus 5y is 0y, which means that I eliminate my y. That's why we call it solving by elimination. So that's what I'm going to do. I'm going to go ahead and add these two equations together. 2x plus 3x is 5x. 5y minus 5y is 0. Negative 24 plus 14 is negative 10. So I've eliminated my y value, and I'm going to solve for x. 5x equals negative 10. Divide both sides by 5, and I get x is equal to negative 2. This is the x value of my solution. Now I need to find the y value of my solution. So I'm going to take one of the equations. 3x minus 5y equals 14. And I'm going to plug in my x value for x. So I'm going to plug in negative 2. We get 3 times negative 2 minus 5y equals 14. 3 times negative 2 is negative 6 minus 5y equals 14. We want to get y by itself, so we're going to add 6 to both sides. We get negative 5y equals 20, divide both sides by negative 5, and I get y is equal to negative 4. So the x value of my solution is negative 2, the y value of my solution is negative 4. The next system we're going to solve by elimination is x minus 10y equals 60 and x plus 14y equals 12. Again, we see that the x terms and the y terms are both on the left-hand side, so that's one of the indicators that solving by elimination is going to be possible. Now, for our x terms, we don't see a coefficient, a number in front of the x. So when I don't see a number, I know that I can always multiply by 1 and it doesn't change the value. So let's think of this system as 1x minus 10y equals 60 and 1x plus 14y equals 12. Now, if I were to add these two equations together, 1x plus 1x is equal to 2x, so that doesn't eliminate, and negative 10y plus 14y is 4y, that doesn't eliminate either. But given that our x values has the same number in front, if I make one of them negative, then they will cancel. So negative 1x plus 1x will equal 0. So that's what I'm going to do. I'm going to take that first equation and multiply both sides by negative 1. That makes my first equation negative 1x plus 10y, because negative 1 times negative 10y is positive 10y. And then negative 1 times 60 is negative 60. Now, when I add my two equations together, negative 1x plus 1x is equal to 0. So my x's go away. Then I have 10y plus 14y is equal to 24y, and negative 60 plus 12 is negative 48. To get y by itself, I'm going to divide both sides by 24, and I get y is equal to negative 2. Now I'm going to pick one of my equations. I'm going to choose x plus 14y equals 12, and I'm going to substitute the value for y. So I'm going to plug in negative 2 for y. I get x plus 14 times negative 2 is equal to 12. 14 times negative 2 is negative 28. So I have x minus 28 equals 12. I'm going to add 28 to both sides, and I get x is equal to 40. So the solution to this system is 40, negative 2. Again, this represents the point, the location on the graph where these two lines intersect. All right, let's solve another equation by elimination. I have 2x plus 3y equals 12, and 5x minus y is equal to 13. Here, if I take a look at my x terms, 2x plus 5x is 7x. If I make one of them positive and one of them negative, it still doesn't cancel. 5x minus 2x is 3x. 2x minus 5x is negative 3x. That doesn't quite work. So then, if I take a look at my y's, I have positive 3y and negative y. Now here at least I have that positive versus a negative if I wanted to eliminate one. The only thing the second y is missing is a 3. So what I'm going to do is I'm going to multiply my second equation. Alright, I'm going to multiply my second equation by 3 on both sides. So the first equation is going to stay the same, 2x plus 3y equals 12. And then I'm going to multiply the left-hand side by 3. So I'm going to distribute that and get 15x minus 3y equals 3 times 13 is 39. Now I'm ready to add my equations together so that my y values will eliminate. So 2x plus 15x is 17x. 3y minus 3y is 0. Those eliminate. And 12 plus 39 is equal to 51. I want to get x by itself, so I'm going to divide both sides by 17, and I get x is equal to 3. I'm going to choose one of my equations, so I'm going to choose 2x plus 3y equals 12, and I'm going to plug in 3 for x so that I can solve for y. 2 times 3 plus 3y equals 12. 2 times 3 is 6, plus 3y equals 12. Let's subtract 6 from both sides, so we get 3y equals 6, divide both sides by 3, and I get y is equal to 2. So the solution to my system is the x value 3, y value 2. So this is the point where the two lines intersect. All right, let's take a look at a challenge solving by elimination. So here's my system. 2x plus 4y equals negative 4, and 3x plus 5y equals negative 3. Now the reason why this is a challenge is if I look at my x and my y terms, neither of them are going to cancel on their own. We know that elimination is probably going to be the easiest way to solve because my x terms and my y terms are on the same side. If I tried to solve for either x or either y, I'm probably going to end up in a fraction. It's a possibility. So let's go ahead and focus on eliminating the x terms. So right now on the top I have 2x and on the bottom I have 3x. So if I multiply the top by 3, that would get me 6x. And if I multiply the bottom by 2, that will give me 6x. So at least I can get the numbers the same. Now I want one of them to be positive and one of them to be negative so that they cancel. So I'm going to choose to make the top one negative. So in order to make the top equation, the x value, -6, I need to multiply through by -3. And in order to make the x value for the second equation +6, I need to multiply through by +2. So when I distribute -3, I'm going to get -6x minus 12y is equal to +12. Then when I multiply the second equation by 2, we're going to get 6x plus 10y equals -6. Now I'm ready to go ahead and add my equations together. -6x plus 6x is 0x, so those are eliminated. I have -12y plus 10y is -2y. 12 minus 6 is 6. To get y by itself, I'm going to divide by -2, and I get y is equal to -3. So now when I go to substitute in the value of y to solve for x, I'm going to choose an original equation. So I'm looking back at my original system and I'm going to choose the first equation, 2x plus 4y equals -4. I'm going to substitute -3 in for y. So I get 2x plus 4 times -3 equals -4. 4 times -3 is -12, so we get 2x minus 12 equals -4. Add 12 to both sides, we get 2x equals 8, divide both sides by 2, and I get x is equal to 4. So my solution is 4, -3. Again, if you have any questions on solving systems of equations, if you have any questions about solving systems of equations, please feel free to look up the additional resources or ask questions on the lessons page. Thanks.